Good morning, dear students, and welcome to the class. Today we will be discussing about Theorem 4. Now Theorem 4 says if f of x is continuous in the closed interval a comma b, they have given this function, okay, which is continuous in the closed interval a comma b, and f of a and f of b. How do we get f of a and f of b here? When you substitute a value in the function, you will get f of a. When you substitute b value in the function, you will get f of b. Okay, and f of a and f of b are of opposite signs. That means one is positive, one is negative. Then f of x vanishes for at least one value of x that is equal to c. That c has to be between a and b. That has to be in the interval a comma b. That is f of c is equal to 0. Okay, let us go to proof part. So before we begin, we will understand by taking an example. I am taking an interval. So this is your real line. Okay, consider an interval as 1 and 4. Logically we can understand now. This 1 and 4 is on the real line. Okay, like that in general, if this is your real line, in general you should think there is an interval a comma b. So he is saying function f of x is continuous in a closed interval a comma b. So we have taken this a and b in general. Okay, now suppose I have a function f of x is equal to 2x minus 3. I will find out what is my function value at 1 as well as what is my function value at 4. So let's find out. F of 1 will give me 2 of 1 minus 3 is equal to 2 minus 3, that is equal to minus 1. This implies what? F of 1 is equal to minus 1, which is obviously less than 0. Correct? So I can write f of 1 is less than 0. In the similar fashion, if I find out f of 4, I will get 2 of 4 minus 3, that is equal to 8 minus 3, that is equal to 5. So I can say now f of 4 is equal to 5, which is obviously positive, which is obviously greater than 0, which implies I can write f of 4 is positive. Okay, in that similar fashion you have to write for f of a and f of b. Here suppose you have function f of x. It can be any function. Okay, here also you will try to find out f of a as well as f of b. F of a should be less than 0, f of b should be greater than 0. Okay, such type of interval is given in the statement. in the statement. We'll go to the statement again and we will see what he is trying to say. See, f of x is continuous in the closed interval a comma b, he is saying, and f of, when you plug in a value in the function, that means f of a is negative and f of b is positive. Okay, that concept. Now how do we move ahead? We will move ahead by defining a subset S of a and b. Okay, defining subset S from this closed interval a comma b, and how the test will be S all values of x taken from a and b only, such that at those points the function will give you negative values. I'll write in words. S is the set of all x values taken from the closed interval a comma b, such that when we plug in those x values in the function, always we get f of x as negative, that is f of x value is always less than 0. This is the meaning of the set which we have defined. This set we have defined, and that is the meaning I have written below. Okay, now since S is finite, this implies S is bounded. That means there is a boundary. Since f is finite, S is bounded. Now we know that bounded means it has got supremum as well as infimum. So to prove this theorem, we deal with only supremum of the set S. So we consider the supremum of S as C. So what is our supremum now? Supremum of the set S is C. Right? So let me write here I have supremum as what? C. We will also call it as least upper bound. Okay, then once we have this, then we can find out the function value at the supremum, that is at C. That is at C. That means we can find f of C. Once we plug in C in the function f of x, there are three possibilities of getting values, like f of C is may come as f greater than 0, f of C may come as negative value, f of C can be equal to 0. I am talking about this. f of C positive value nu barbodu, f of C negative value nu barbodu, or f of C can be equal to 0. Okay, now we will discuss the cases one by one. Let us consider this as first case, this as second case, and this is as third case. Let's take cases one by one. When or you take suppose f of C is greater than 0. f of C is greater than 0. So ಈ ಕೇಸ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ we should know one concept called as neighborhood. I am writing here neighborhood. Okay, suppose you have an interval a comma b. Okay, in between you have value c. As an example, you take this as 1 and 4, this you take it as 2. Okay, when you add some point, okay, I am writing here at the down. Suppose we have considered c is equal to 2, right? So I will consider delta 1 value as 0.1. Okay, from this c plus delta 1 will be equal to 2 plus 0.1, that is equal to 2.1, right? If I try to find out c minus delta 1, I will be getting 2 minus 0.1, that is equal to 1.99. So we will see when we try to add 0.1, I am getting what? 2.1. Here we are moving to the right hand side. So this point we call it as c plus delta 1. Okay, to the value of c you have added some point called some point you have added delta 1. In the similar way, when you subtract point 1 from C, you will move to the left hand side, and you will get what, 1.9 as the point, and that you call it as C minus delta 1. Okay, now we have got an interval C minus delta 1 and C plus delta 1. So when this case happens, suppose f of c is positive, the theorem says there exists a neighborhood C minus delta 1 comma C plus delta 1 such that f of x value will always be greater than 0. Now let me write that here again. This is my A, this is my B, okay, this is C, this is C plus delta 1, this is C minus delta 1. Now listen carefully. C is only the supremum which we have assumed, right? So this part may not exist, or we'll say latter case is not required only. We will not consider this case. ಯಾವುದು C ಇಂದ C plus delta 1 values ಏನೇನು ಬರುತ್ತೋ those cases doesn't exist ಅಂತ ಹೇಳ್ತೀವಿ. Okay, also f of x is greater than 0 in the interval C minus delta 1 and C plus delta 1. andre this is A, this is B, this is C, this is C plus delta 1, C minus delta 1. In this interval f of x is positive, but the set S is defined such that f of x has to be less than 0. So this contradicts to the fact that the set S has all the values of x belonging to closed interval a comma b such that f of x is less than 0 which implies we arrive at a contradiction that f of x value greater than 0. So case 1 is not possible. Case 1 is not possible. That is, at C, f of C cannot be greater than 0 ಅಂತ ಹೇಳಿ case 1 ನ finish ಮಾಡಿ. Okay, if we are trying to understand graphically ನೋಡಬೇಕಂದ್ರೆ in the previous classes we might have studied to draw functions. Suppose you have y of x is equal to 2x and you'll find out, if you want to draw any graph, what you'll do, you'll find out x and y values, right? When x is 0, you'll put and you'll substitute in y of x, you'll get y as 0. When you put 1, you'll get y as 2. When you put x value as 2, you'll get 4. When you put 3, you'll get 6. When you put 4, you'll get 8, right? So like this we used to draw the graph. How the coordinates now? This is 0, 0. This is 1, 2. This is 2, 4. This is 3, 6. This is 4, 8. This is our x value. This is our function value, right? Function value at x. Function value at x. ಅಂದರೆ ಫಂಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲಿ ಬರುತ್ತೆ? ಈ ಸೈಡಲ್ಲಿ ಬರುತ್ತೆ. ಫಂಕ್ಷನ್ ವ್ಯಾಲ್ಯೂಸ್ ಪಾಸಿಟಿವ್ ಇದ್ದಾಗ ಮೇಲ್ಗಡೆ ಬರುತ್ತೆ, ನೆಗೆಟಿವ್ ಇದ್ದಾಗ ನೆಗೆಟಿವ್ ವೈ ಆಕ್ಸಿಸ್ ಮೇಲೆ ಬರುತ್ತೆ. ನೆಗೆಟಿವ್ ಫಂಕ್ಷನ್ ವ್ಯಾಲ್ಯೂಸ್. Negative function values. Let us draw these coordinates. This is 0, this is 1. X value, x range I am writing 0, 1, 2, 3, 4. Okay, at 0, let me write this also. 0, 2, 4, 6, also 8. Now understand what I am trying to say. At 0, what is your function value? 0, right? At 1, what is your function value? 2. At x value as 2, the function value is 4. Okay, at 3, the function value is 6. So that means at 0, from here, at 0 you are finding f of 0 equal to 0, right? At 1 you are finding f of 1 is equal to 2. At 2 you are writing f of 2 is equal to 4, like that, like that, like that. Suppose you have, suppose you have an interval a comma b, correct? So at a, the function value will be f of a. Think, suppose it is here somewhere, okay? At b, the function value will be f of b, okay? Now at c, the function, what value will be given? What value we will get for c? F of c. Compare these two now. If you have any doubts, compare this. So here I said, in the first graph I said at 1 f of 1 I'll get f of, at 1 I'll get f of 1 value, at 2 I'll get f of 2 value, at 0 I'll get f of 0 value. Here at a I'll be getting f of a value, at b I'll be getting f of b value, at c I will be getting f of c value. Okay, f of function values where we are defining on the y-axis. If it comes here, it is positive values. If it goes down, it is negative function values. Okay, in the first concept they said f of x is positive. Okay, f of x, condition when f of x is positive, they said in the neighborhood, this one c plus delta 1, c minus delta 1, f of c is positive, correct है ना? So c value क्या है? C value we have defined over here. So at c I am getting f of c which is in the positive direction. Okay, similarly when you put these values from the interval, everywhere the function will be positive. In the same, with the same concept, the second case is coming. If f of c is less than 0, ಈ ತರ ಆದಾಗ ಏನು, f of c is less than 0. f of c less than 0 ಅಂದ್ರೆ ಅರ್ಥ f values are on the negative x-axis. f of c less than 0 ಅಂದ್ರೆ f values are negative for these intervals, for the values of x. You have a and b, similarly you have c. Similarly you will be defining, now you define something, c minus delta 2, c plus delta 2. Okay, at c I will be having f of c here in the negative part. This is, everything is negative. So here also you will be getting somewhere like this, here also you will get somewhere like this. For this x value you will get y value like this, which are all negative, which are all negative. Now contradiction part we are writing. Understand carefully. This is RA, this is RB, this is RC. Here we have C minus delta 2, C plus delta 2. Since C is only the supremum, here I'll write at the values between C and C plus delta 2, we are getting f of x values as negative, but we cannot have two upper bounds. Which two upper bounds we are getting? One is C, this we have considered, this C plus delta 2 we are getting. So these two with together not possible. This implies this is contradiction. This implies this is contradiction to the fact that C is upper bound. C is upper bound of S. Therefore, f of C cannot be less than 0. That is, f of C less than 0, not possible. Therefore, case 1, that is f of C greater than 0 is not possible. Case 2, that is f of C less than 0 is also not possible. Therefore, the only possibility is f of C is equal to 0. Hence the theorem.